Let's try another example with that complex number involved. I see here we have a fourth degree polynomial with zeros at x equals -1, -1, and 3i. Because it is a fourth degree, we know we need 4 terms. And because we have this 3i, that means we also have its complex conjugate, which is -3i. So what we're going to do is we're going to write this in factored form. So we have that f of x equals x plus 1, because it's x minus a -1, times x plus 1, times x minus 3i, times x minus a -3i, or x plus 3i. So first we're going to go ahead and FOIL out the x plus 1 times x plus 1, which is x squared plus x, so plus 2x, plus 1 times 1, which is 1. And then I'm going to use my shortcut for this second part, and I'm going to have x squared plus the sum of my complex one, so 3i minus 3i, which is 0, so I'm going to leave that out, plus the product, so that would be -9i squared, which, remember, -9i squared is -9 times -1, which is +9. And so to rewrite this, I've got x squared plus 2x plus 1 times x squared plus 9. So now I'm going to go ahead and FOIL this all out. And so I'm going to go this way because it'll make my life easier, because this one is less terms. X squared times x squared equals x to the 4th. X squared times 2x is 2x cubed. X squared times 1 is x squared. And then we have 9 times x squared, which is 9x squared. 9 times 2x is plus 18x. 9 times 1 is 9. So then I can find my common terms. I've got a 2x cubed that is all by itself, and an x to the 4th that is all by itself, which means that f of x is equal to x to the 4th plus 2x cubed. And then I've got x squared and 9x squared, so plus 10x squared, plus 18x, plus 9, which is a lot shorter of a route than if we were to go down the road of using our actual foiling out. Looking at now what happens if we have radical zeros. It's the same case in that we're going to find the other radical 0. If we have 1 plus the square root of 2, our other 0 is going to be at 1 minus the square root of 2. So if we were to write this out in factor form, we have x minus 1 plus the square root of 2, and times x minus 1 minus the square root of 2. Now, if we were to go ahead and FOIL this out, it would get really messy really quick. So if we use our trick, we have x squared times the sum of these. If we take this and we add it, 1 plus 1 is 2, and 2 minus the square root of 2 is 0, so this would be plus 2x. And then we take the product, and we do have to FOIL that out. 1 times 1 is 1. 1 times the negative square root of 2, 1 times positive square root of 2, those cancel. Square root of 2 times negative square root of 2 is 2. And so that would be -1, so our function is f of x equals x squared plus 2x minus 1. Trying one more example. If we have 2 plus the square root of 3, my other radical 0 would be 2 minus the square root of 3. And then we can go ahead and write this as our f of x in factor form. We have x minus 2 plus the square root of 3 times x minus 2 minus the square root of 3. And then we can go ahead and, as I mentioned, I'm going to put in here the factored form and the standard form. We can go ahead then and have f of x be equal to x squared plus the sum. 2 plus 2 is 4, 3 minus the square root of 3 is 0, so plus 4x. And then when we FOIL those out, 2 times 2 is 4, minus 2 root 3 plus 2 root 3, those cancel. And then square root of 3 times square root of 3 is 3, so we would have 4 minus 3, which is 1, which makes our final function f of x equal to x squared plus 4x plus 1. Your job now is to go ahead and try the U-try problems. We have 3 of them here. One with radical, one with complex, and one with integers. And write your summary and bring your questions with you to class tomorrow.